Number one, Safi conducted a study to see if there is a relationship between the price of an apartment, Y, and its distance, X, from the city center of Melbourne. They took a random sample of 6 typical apartments along a train line in the city. Safi obtained the data shown in the following table. This is the data, and the plot of this data is in the following graph. This is the graph, the scatter plot of data. Okay. Write down the value of Spearman's rank correlations coefficients are as. All right. Actually, you can input this data into your calculator and you can determine the correlation, but I would like to show you how we calculate manually. Firstly, I would like to create the table, this column in kilometers. Okay, 7.0, 8.4, this is the data, 10.3, 12.5, 17.8, and 20.9. Or that Y, okay, in million, 2.61, 2.44, 2.03, 1.81, 1.45, 1.18. And we are going to create the next column is rank, okay. Rank of X. Of X. Okay, this is 1, 2, 3, 4, 5, 6. So this is for data from the lower to the highest. This is the first, second, third, fourth, fifth, and sixth. After that, rank Y. Rank Y. So the first, second, third, fourth, fifth, and the sixth. 4, 5, 6. Right. After that, we are going to find D, the difference. 1 minus x minus y, 1 minus 6 minus 5. This is minus 3, 2 minus 5, and then 3 minus 4, 1, 3, and 5. And then d squared. D squared, 25, 9, 1, 1, 9, 25. Okay. So we're going to calculate this is 70. And RS equal 1 minus 6 times sigma. Sorry, this is sigma actually. Sigma d squared over n times n squared minus 1. It means 1 minus 6 times 70 over 6, 36 minus 1. Divided, 1, 1 minus 70 over 35. 1 minus 2, it is minus 1. Okay. This is the correlations according to the Spearman's rank correlation coefficient. Next, part B. Find the present product moment correlation coefficient R. We'll move here. Part 1. I'm going to create table as well. Again, you can calculate this through your calculator. If you got a scientific calculator, but I would like to show you how we calculate manually. The data same 7.0, 8.4, 10.3, 12.5, 17.8, 20.9, 2.61, 0.44, 2.03, 1.81, 1.45, 1.18. But we are going to calculate sigma of this data, 76.9, and this one. And the sigma is 11.52. After that, x squared. This data squared, 49, 70.56, 106.09, 156.25, 316.84, 436.81. The accumulation, the sigma, 1135.55. After that, y squared, this column squared, data squared, okay. 2.61 squared, 6.8121. This is data squared, 5.9536, 4.1209, 3.2761, 2.1025, 1.3924. And accumulation equal 23.6576. After that, x times y. Wait. Okay, x times y. And 7.0 times 2.61 and so on. 18.27, 20.496, 20.909, this one 22.625, this one 25.81, this one 24.682. And if you calculate the accumulation is 132.772. So we're going to find the coefficient correlation. R, according to the formula, that is n equals 6, okay, times this one, xy, 72, I think this formula familiar for you. Okay, over square root n is 6 minus 76.9 squared. Okay, 23.76 minus squared. And the result is, you can find the result 0.9791. That one. So this one already. Use your value of R to state, of R this one, I mean, to state which two of the following will best describe the correlation between the variables. Okay, so two, based on the R value, the best description, okay, of the correlation. The correlation is first, okay, first, since since R is negative, since R is negative or is minus, okay, it means as the distance increases, okay, the price tends to decrease. So the relation, the correlations, so the correlations is negative as well. Second, since the absolute since the absolute value of R close to 1, close to 1, so please, okay, this one, sorry, not one. Oh, sorry, this one, I mean, close to 1 minus 0.791, close to 1, even minus. It indicating, it's indicating a strong linear relationship if close to 1. So the correlation is strong. So strong and negative. Right. What else? Next question. Write down the value of A. So if you look this data just now, you can see that between the apartment and the apartment data, and then the distance that look the scatter plot. If you create the strike line, okay, it tends to uh, the slope would be minus, or the gradient would be minus. So that's why just now the correlations is negative, right? Okay, we're gonna find A and B. A and B. Part C1. So we need to calculate the equation, the regression line equation that y equal ax plus b. So this we are going to determine a and as well b. And the formula of a is n sigma xy minus sigma x times sigma y over n times sigma x squared minus sigma x squared. And this is 6 times, according to our previous calculation, 132.772 minus 76.9, 11.52 over 6 times 1,135.55, 76.9 squared. And if you calculate, the result is minus 0.09. 207, so on, and round off becomes minus 0.0992. That's one. A. Next, B. B is y intercept. If you create the graph like this, usually we create that if this is y, this x-axis, that, and there is a graph like this, a strike line. This actually coordinate point, this coordinate point, that is the value of B. And the B formula sigma y minus sigma minus A sigma x, sorry, over n. Sigma y is 11.52 minus 6. Okay. Sorry, minus not 6, minus A. A is 1 minus 0.0992. This one, 99207, so on, times 76.9 over 6. And the result, if you calculate, 3.1915. So on, round off becomes 3.19. So on. Next question, part 3. See part 3. According to this model, state in context what the value of B represent. Okay, in this context, right? Part 3. So in this context of this study, uh, the y-intercept, as I inform you just now, the y-intercept or B is the predicted price is the predicted price of an apartment when the distance when the distance x the distance x is distance uh when the distance from the city center. One. Next, deep one. As we see the question, D. Safi uses the regression equation to estimate the price of a typical apartment located 19.6 kilometers from the city center. Find this estimated price, right? So A, just now we are going to calculate A equal minus 0.0999207, and then B is 3.19. So the regression equation is y equal, this is A, minus 0.0992 x, okay, plus 3.19. Next, okay, now substitutes, according to the information that substitute x equal 19.6, substitute x into y into this equation, and it's going to be minus 0.0992 times 19.6, okay, plus 3.19. And if you calculate, the result is 1.24704. So on, round off, it becomes 1.25. So the estimated price, so the estimated price of the apartment located at 19.6 km, 19.6 km from the city center, from the city center, uh, is approximately 1.25 Australian dollars, because in Melbourne, right? Part two, State two reasons that Safi might use to justify the validity of this estimate. Okay, part two. Right, I would like to writing the distance of 19.6 kilometers is within the range of observed. Okay, it's within the range of observed data of the observer, I think, 7.0 kilometers to 20.9 kilometers according to the data. Okay. When making prediction for values that fall within the range of the data, and the process we call as interpolation. Interpolation. Okay. This is the first. The second. Okay, the second. The data shows a strong negative linear relationship. To be, I have to prepare first this one. Basically, I will writing this between the price data, uh, the price of an apartment, and its distance. Its distance from, of course, from the city center. From the city center. Okay. This strong means that there is a consistent and predictable relationship, predictable relationship of variables. There are two variables. Okay, relationship of two variables. Okay. Next question. To verify whether this relationship applies in a different direction from the city center, SAFI considers two locations, A and B, both an equal distance from the city center. They take a random sample of 7 apartments from each location and record the price in millions of dollars in the following tables. These are the data, the table. Safi conducts a t-test at 5% level of significance to see if the mean apartment price in location A is different to the mean apartment price in location B. They assume the population's variances are the same. For this test, Safi takes the null hypothesis to be mu A equal mu B. Write down the alternative hypothesis, right? So I put alternative hypothesis. Okay. Okay, alternative hypothesis is mu A unequal mu B. Okay. F. Find the p-value for this test. Right. The first step, you need to find the mean A. How to find mean A? Look the data on the table. Okay, mean A is 1.21 plus 1.25 plus 1.31 plus 1.32 plus 1.58 plus 1.95 plus 1 plus 2.13 divided by 7 over 7. So the result, mean A is 1.535714. And mean A with mean B, I mean with the same procedure, I can determine 2.26714. Well, and the second step, we're going to find uh, the pool standard deviation. Okay. And first, for A, for A, look this data for standard deviation. So we start from 1.21 minus mean 1.25 minus mean 1.31 and so on until 2.13 minus mean. And after that, square, right? So it's going to be 1.21 minus mean 1.535714 squared and 1.25 minus 1.53714 squared plus 2.13 minus 1.535714 squared over 7 minus 1, and the result is 0.135329. That is for location A. Now for location B. For location B, 1.51 minus this one, 2.26714 squared, 1.58 minus 2.26714 squared, so on, 2.95 minus 1.535714 squared over 7 minus 1. And the result, 0.41037. So that the standard deviation of population is equal to square root, the formula, and a minus 1, and a is 7, times SA squared, standard deviations of A, and B minus 1, and then SB squared over NA plus NB minus 2. It is square root 7 minus 1, 6. 6 times standard deviation of A, 0.135329. 0.410357. 7 plus 7 minus 2. And the result is square root 0.272843. The result is 0.5222344. 6 decimal places. Next. And the third step, we're going to calculate the statistic test. Okay. T-test, I mean. And the formula is T equal, okay, mean of A minus mean of B over standard deviation 1 over and A plus 1 over n B. Mean A is 1.535714 minus 2.267143 divided by 0.522344. Square root 1 over 7, 1 over 7, 1. And if you calculate, the result is minus 2.619684. Okay, and it gives the statistic value approximately minus 2.619684. Yeah, so this possibility is lots of number, and 6 decimal places one little number. And the fourth step, we are going to determine the degrees of freedom. Degrees of freedom is NA plus NB minus 2. It equals 7 plus 7 minus 2 equal 12. And the fifth step, we are going to find the p-value on calculator when t equal minus 2.619684, then level significance, okay, level of significance, the level significance is 0.05, and then the F 12. So we get the p-value. If you calculate on your calculator, the p-value equals 0.0222426, or round off becomes 0.0224. So this is the p-value. Next question. State the conclusions of the test. Justify your answer. Okay. G. 0.0224 less than level significance 0.05. So, or p-value less than a level of significance. So the conclusion, we can state that reject the null hypothesis. Reject the null hypothesis. It means there is a statistically significant difference in the mean apartment prices between location A and B. One. And next, the question, state one additional assumption Safi has made about the distribution to conduct this test. Okay. H. Safi has made to conduct this t-test this t-test, sorry, this t-test that okay that the two population two the two population the two populations A and B are normally distributed. Okay, so normally distributed. Number two, the company Freight Express delivers packages from past experience. The time taken T to deliver a package follows a normal distribution with mean 64 hours and standard deviation 12 hours. State probability that t less than 64. Right. The probability that t less than mu. Okay, and which mu is 64. The probability t less than mu, that is always zero point 0.5. Why? Because the normal distribution is symmetric around the mean. That's, so it means we can state that probability t less than 64, because mean equals 64, is always zero point 0.5. B. Find probability t greater than 44, less than 64. Okay. So we are going to standardize the values by C-score with this formula T equal T minus mu over sigma. Okay, which mu equal 64. This is mean. This one, and then sigma is standard deviations equals 12, and T is the value of interest. Next, if T equal 44, so it means Z equal 44 minus 64 over sigma 12. It is minus 1.67. If T equals 64, so C equal 44 minus 64 over 12, and it is 0. Okay. So the probability T greater than 44, less than 64, correspond to probability Z greater than minus this one, 1.67, less than 0. Okay, according to this calculation. So it means probability Z 0, Z less than 0 equals 0.5. Okay, and then the probability of C less than minus 1.7, 1.67, that is 0.0475. You have to find this probability through table or calculator. You may calculate this. And it means the probability that Z greater than minus 1.67 less than 0 is equal probability Z less than 0 minus probability Z less than minus 1.67, and it equals 0.5 minus 0.0475, and it equals 0.4525. That means we can state that probability T is one greater than 44, less than 64, it equals 0.4525. So, 50% packages are delivered in less than key hours. Sketch a diagram of this normal distribution setting the region that represents probability that K greater than T. Okay, K greater than T. Okay, we are going to sketch this normal distribution. Okay, it is mean. Mu is 64 here. This is mu. Okay, and according to this information uh, that t less than 64, uh, uh, t less than mu, t less than 64. So it means t located at the left side. Okay, so it means k on around here. This is k, and this is t area. All right, this is mu. Okay, C part 2. Find the value of k. So we are going to standardize t to the standard normal variable z according to the previous formula that c equal t minus mu over sigma. Fine. And the cumulative probability, the cumulative probability z less than c, uh, this is uppercase, this is lowercase. I think you understand this is 0.3. Correspond to the this is correspond to the C score, and it satisfies this condition. Okay, you can using the standard normal table or calculator, okay, to find that this probability. It means to find z, the lowercase z is minus 0.524. If you have standard normal table, you can find this number, or you can find through calculator. Now, convert z to t. We are going to convert z into t according to this formula that z equal k minus mu over sigma, because this one k on this area, on this t area, right? So how to convert? K equal sigma times z plus mu, that is k. And then it becomes sigma is minus 0.524, z is 12 plus 64, and it equals 57.712. Round off becomes 57.7 hours, the unit. Okay, 57.7 hours. That is K. Head Express, oh, this one, D first. For quality control, the manager randomly selects 5 outgoing packages. The selections are independent. Find the probability that exactly 2 of these packages are delivered in less than K hours. Okay, so D. This is a binomial probability problem, actually. So we have to calculate that the probability t less than k equals 0.3. So it means, if this probability, it means p 0.3. The probability equals 0.3. The formula for the probability of exactly X success in n trials, okay, in a binomial distribution is this one, x uppercase, x lowercase, the combination, and you are familiar, I think you are familiar with this formula, x, this is q n minus x. Q is 1 minus p. So, or probability x equal to combination 5 and 2, 0.3 squared, 0.7 cube, because q is 1 minus 0.3, right? And 3 is n minus x, right? And it's going to be 0.3087. If you calculate, you're going to find this number. So the result, that one. Next, E. Freight Express charges a fixed amount of $4.50 for any package weighing 1 kg or less. If packages are charged an additional fee of $2 per kg. This fee is applied for any weight in excess of 1 kg. For example, a 1.5 kg package is charged an additional $1. Write down an expression for the amount charged to deliver a package of weight x kg where x greater than 1. All right. So the excess weight beyond 1 kg, okay, the excess weight beyond 1 kg is x minus 1. Okay, so additional charge, the additional charge, the additional charge 2x minus 1. And the total charge is 4.50 plus 2.00 times x minus 1. It's going to be 4.50 plus 2.00x minus 2.00. 4.5 plus 2.00 is going to be uh, 2.00x, and it is minus, plus, because 4.5 minus 2, 2.5, 2.50, this one. That is for x greater than 1. Next, find the amount Freight Express charges for 5.3 kg package. Okay. F. F. The charge, total charge, is 2.00x plus 2.50. Now substitute x equal 5.3 into this expression. 2.00 times 5.3 plus 2.50. And if you calculate, the result is 13.10. Okay, for okay, for a 5.3 kg package. Okay, so $13.1 for a 5.3 kg package. Next, mailing is charged $7.2 for delivery a package. Find the weight of mailings package. Okay. G. Again, charge. The charge expression is 2.00x plus 2.50. And mailing charge $7.2. Substitute into this equation becomes 7.20 equal 2.00x plus 2.50, right? So it means 2.00x equal 7.2 minus 2.50. So 2.00x equal 4.70. X equal 4.70 over 2.00. It equals 2.35. So the weight of mailings package is 2.35 kg. Number three, a shop uses the following model to estimate n the number of smoothies sold per day in terms of X. Okay. The price of a single smoothie in pesos. So X is the price. Okay. Single smoothies in pesos. Right. This is the equation n equals 40,000 over X squared. The maximum number of smoothies in the shop can make in a day is 400. Find the maximum price they could charge per smoothie for the shop to sell 400 in one day. Okay. A, the number of smoothies is 40,000 over X squared. Right. If n number of smoothies is 400, so it means this equation becomes 400, 40,000 over X squared. Okay. Or X squared equal 40,000 over 400. It is 100. So X equals square root 100. And this is 10 pesos. Yeah, we got X is the price according to the information. Next part B, B1. On a day when the shop sells smoothies at 50 pesos each, use the model to find the number of smoothies sold, the total income from the smoothies sold. Okay. If X equal 50, if price equal 50, so the number of smoothies equal 40,000 over 50 squared, and 40,000 over 2,516. So when the price, when X or when the price is 50 pesos, 50 pesos, uh, it means the shop will sell. Yeah, will sell 16 smoothies. All right. So the part two, we're going to find the total income. The total income equal uh, number of smoothies, 16 times the price equal 800 pesos. C. Oh, this one. The cost of making each smoothies is 20 pesos. The profit per day is the total income from the sale of smoothies that day minus the cost of making them. So that according to the model, P equal 40,000 over X minus 800,000 divided by X squared. Okay. Sorry, C, that one is, yeah. Oh, okay, the number of smoothies is right. Okay, C part one. So the total income equal number of smoothies times price. Okay, it equals 40,000 over X. That is equation for the equation for income. Next, the equation for total cost. For total cost is cost per smoothies times the number of smoothies. Okay, so it means cost equal 20 times 40,000 over x squared. Cost per smoothie is 20 and number of smoothies is 1. The expression so becomes 800,000 over x squared. Profit equal income minus cost. So the income expression is 40,000 over x minus cost expression is 800,000 over x squared. So this is the equation for profit. X, C part 2. Find dp over dpdx, not over. The differential. The differential of this equation. This is the equation. I'm going to change becomes 40,000 x power minus 1 minus 800,000 x minus 2. And dx, the differential is minus 40,000 x power minus 2 plus, because minus 2 times 800,000. So it's going to be 1,600,000 x minus 3. Okay, so this is the difference, or uh, you may write thing like this: minus 40,000 over x squared plus 1,600,000 over x cubed. So find the value of x for which dpdx equals 0. Okay, dpdx equals 0, it means that is the maximum profit, right? So maximum profit if dpdx equals 0, minus 40,000 over x squared over x cubed equals 0. Okay, and multiply by x cubed. Multiply by x cubed, it's going to be minus 40,000 x 1 million, sorry, 1,600,000 equal 0. Or 40,000 x, well, 1,600,000 x equal, divided uh, divided by 40,000. Okay, and uh, the result is 50. So x equal 50. If dpdx equals 0, x equal 50. Find the number of smoothies sold when the profit is maximized. Okay. If the profit is maximized, the maximum profit if dpdx equals 0, so x equal 40. We just substitute x equal 40, substitute x equal 40 into this equation, number of smoothie, 1,000 over x squared, 40,000 over 40 squared, 40,000 over 1,600, it is 25. So we can state that the number of smoothies, sold when the profit is maximized in 25 smoothies. Number 4, a type of generator will only function if a particular switch is working. The generator has a main switch A and a backup switch B. The manufacturer claims the probability of switch A failing within 1 month of being fitted is 0.1, and the probability of the cheaper switch B failing within 1 month is 0.3. Whether or not a switch fails is independent of the state of the other switch. If both switches fail, the generator needs to shut down to replace the switches. Both switches are replaced after a month of use, whether they have failed or not, or whenever the generator needs to be shut down. The following three diagrams shows the probabilities of a switch failing within 1 month of them both being replaced, assuming the manufacturer's claim is correct. Is question. Write down the values of A, B, C. Okay. If this is 0.1, it means A is 1 minus 0.1. And this is 0.7. So A is 0.7. 0.7. Next, B. According to this information that we can state that B equals 0.3, it's 1, 0.3, and C is 1 minus 0.3 equals 0.7. Sorry, this is 0.9. Sorry, this is 0.9. 0.7. So this is 0.9. Because 1 minus 0.1. So B is 0.3 and 0.7. Okay. Hence, find the probability that the generator needs to shut down within 1 month of the switches being replaced. If you look the information here, at here, this one, that the probability of shutdown, okay, it means fail. So it could be, according to this information, that if shutdown, okay, you can analyze by yourself the probability shutdown 0.1 times 0.3, 0.03, 1. C. How this one? The owner of the generator is suspicious of the switch manufacturer's claims. So they look back through the past 200 occasions when the switches were replaced. The records show whether no switches, one switch, or two switches had failed. Okay. The data the owner collected are shown in the following table. This is the data so that the expected failure of no switches failing in the generator during the last 200 occasions when the switches were replaced is 126. Okay. So the probability, that's part C, probability that A fails, according to the information, is 0.1. And the probability of B fails, that is 0.3. You can look at the information on the upwards. And then of number of occasion, number of occasions observed, well, 200. That according to the information. And the next important information that the failure of switch A and B are independent event. Okay, here. So now if you look this one, it's the independent event you can here. Okay, it's independent event. Okay. So we need to calculate the expected number of occasions where no switches fail. No, no switches fail. We need to calculate. But so it means the probability A does not fail equal 1 minus 0.1 because probability A fails is 0.1. If it does not fail, it means 1 minus 0.1, 0.9. And probability B does not fail equal 1 minus 0.3, 0.7. So it means the probability no switch, probability of no switch fails is equal probability A does not fail, intercept with B does not fail. And it is, if the interception, it means 0.9 times 0.7 equals 0.63. And next, we are going to calculate the expected value. So the expected value, sorry, I mean this expected value. So the expected value of no switches of no switch, sorry, no switches failing uh, equal to 100 times 0.63 is 126 one. Part G. Perform a T-squared goodness of fit test at the 5% significance level. So alpha is 5%, 0.05. Refer to the test whether the manufacturer's claims are correct using the following hypothesis. For the null hypothesis, the manufacturer's claims are correct. And the alternative hypothesis, the manufacturer's claims are not both correct. So we need to find the probability with no switch. No switch fails. 0.9 times 0.7. Just now we already calculate this 0.63, this one. And the probability one switch. I would like to find the I will find the expected frequency. So the expected frequency of this of no switch fails, no switch fail equal 200 times 0.63. 200 times 0.63 is 126. Next, we're going to find the probability one switch fails. Okay, one switch fail, but I would like to find first to calculate first the switch A fails, but B B doesn't fail. Okay. It is 0.1 times 0.7. 0.07. You may evaluate the diagram, this one, on this diagram. Okay, this one diagram. Okay, if 0.1 and uh, if you 0.9 and 0.7, if not fail, not fail. Okay, if fail is 0.1 and 0.3. Okay. Okay. And next, if switch B fails, but A doesn't fail. Okay, but A doesn't fail. It's without S. Sorry. It is 0.9. You may evaluate with the diagram. times 0.3, 0.27. So it means the probability one switch fails is 0.1, 0.1 times 0.3. It is 0.03. And next, the probability, that are three parts, one, two, three. Okay. The probability of two switches fail, it is 0.1 times 0.3, 0.03. And the expected failure, just now I will calculate as well, the expected failure of two switch fail is 200 times 0.03. It is 6. And after that, I would like to calculate the expected value of one switch fails. 200 times 0.34. It is 68, right? And next, about chi-squared test statistic. Chi-squared, or chi-squared, the chi-squared test statistic. Okay. And the formula is chi-squared equals sigma OI minus EI squared over EI. OI is observed frequency and EI is the expected frequency for each category. Okay, so now for the first category, for no switch failing, that is for no switch failing, let's do 118 minus 126 squared over 126. It is 64, 126 over 126, 0.5079. One. And next, for one switch failing, it is 72 minus 68 squared over 68. It is 16 divided by 68, 0.2353. Next, for two switches failing, it is 10 minus 6 squared over 6, 16 over 6, and it is 2.6667. So chi-squared is the accumulations of the result squared equals 0.5079 plus 2353 plus 2.6667 equal 3.4099. And degrees of freedom is 3 minus 1, it equals 2. This is the degree of freedom. So it means p-value you may calculate on your calculator or uh, on the chi-square table based on this information that this is the calculation and this is the DF chi-square calculation. So p-value is 0.1818, round off becomes 0.182. So it means if you compare with alpha, alpha is 0.05. Okay, so 0.182 uh, greater than 0.05, or p-value greater than alpha. Alpha is is the significance level. So it means is the conclusions is we are going to reject reject null hypothesis and accept alternative hypothesis. So H1 accept. Sorry. So this the conclusion reject null hypothesis and accept alternative hypothesis. Number 5, Andrew designs a fiberglass water slide for a water park. Let X be the horizontal distance in meters from the start of water slide. Let H be the height in meters of water slide above the horizontal ground. The following diagram shows a cross-sections of the water slide. The water slide will be supported by a concrete structure represented by the shaded region in the diagram, this diagram. It is known that derivative of hx equals 0.6x squared minus 1.x. Find the gradient of the water slide when x equal 2. So just substitute x equal 2 into this equation. 2 equals 0.6 times 2 squared, 1.8 times 2. And if you calculate, the result will be 2.4 minus 3.6 minus 1.2. So the gradient of the water slide when x equal 2 is minus 1.2. So the gradient. Next, find an expression for hx. We need to find hx. It means integral of derivative hx. So integral, I mean hx equal integral of hx dx. So integral 0.6 x squared 1.8x dx, and it is 0.6 divided by 3 x cubed, 1.8 divided by 2x squared plus c, and it is 0.2 x cubed minus 0.9 x squared plus c. Now, we're going to substitute h equal 1.4, h 1.4, and x equal 4 into hx, because we are going to find c, okay? Because according to the information that x equal 4 and h equal 1.4. So it means 1.4, okay, this is hx, 1.4 equals 0.3, 0.2 times 1, 4 cube, 0.9, 4 squared plus c, 1.4. This is, if you calculate 0.2 will be, yeah, I have calculated this, that 1.4, okay, I would like to, that c equal 1.4. This is, if you calculate, is 1.6, okay, minus 1.6. So it becomes 1.4 plus 1.6 equal 3. So hx equals 0.2x cubed minus 0.9 x squared plus 3. So this is the original design. Sorry, the original design. Because later we are going to find an updated design. Okay. Write down an integral that can be used to find the area of the shaded region. This area, this shaded region. Okay. 0 to 4. 1, the shaded region equals integral 0 to 4 of hx 0.2x cubed 0.9 x squared plus 3 dx. And yeah, this is the integral part 2. Find the cross-sectional area of the concrete structure. Okay. As we continue this integral 0 to 4, integral of this expression 0.05 x over 4, 0.3 x cubed plus 3x 1 And then after that, substitute 4 and 0 into this expression. 0.05, 4 over 4, 0.3, 4 cube, plus 3 times 4, minus 0. If you substitute 0 here, here, and here, all of this becomes 0. So it's going to be 12.8, 19.2, plus 12, 5.6 square meter. That. Next, part D. Okay, now this concrete structure. But D, find the volume of this concrete structure. Look that the length is 4 and the width is 1.2. This area we have calculated this. Okay. This area, the surface of this concrete structure, same with this area. So it means we are going to calculate the volume equal area times width. Okay, equal area is 5.6 square meter times width is 1.2 meters. And if you calculate, the result is 6.72 meters cube. Next, part E. To comply with safety regulations, Andrew updates this design. The start of the design will stay the same. Then, over the domain x from 2 to 4, the updated design must satisfy the following condition. It's x equal ax squared plus bx plus c. It's 4 equals 1. It's derivative 2 equal minus 1.2, and derivative 3 equals 0. Write down 3 equations in terms of ABC using the given condition. Okay. E. For H4 equal 1, if it's x equal ax squared plus bx plus c based on the information. So it means if you substitute 4 into this x, hx becomes a times 4 squared plus times 4 plus c equal 1. And it is 16a plus 4b plus c equal 1. This is the first equation. Okay. Next, for derivative derivative of hx, if x equal 2, the result is minus 1.2 for derivative hx, 2ax plus b. If you find the derivative of differential of this function becomes like this. So it means 2a, okay, 2a times 2 plus b minus 1.2. Okay, so it means 4a plus b equal minus 1.2. This is the second equation. Next, for uh, H derivative equals 0, okay, according to the information. So it means 2a times times, sorry, 3, or this is 3, I mean, according to this information. This one, okay. So 2a times 3 plus b equals 0. And it is 6a plus b equals 0. This is the third equation. Next, from the second and the third equation, for a plus b minus 1.2, and it's 6a plus b, 0. Now, b minus b equals 0. This is minus 2a equal minus 1.2. Means a equal minus 1.2 over minus 2. And it equals 0.6. And after that, substitute a equals 0.6 into 6a plus b equals 0. So substitute times 6 times 0.6 plus b equals 0. So b equal 6 multiply 0.6 minus 3.6. So that is b. And how to find c? Just substitute a and b. Substitute a and b into this equation, 16a plus 4b plus c equal 1. If a equals 0.6 and b equals minus 3.6, 0.6, 3.6 plus c equal 1. So if you calculate, if you continue to calculate, it becomes 1 minus 9.6 plus 14.4, and the result is 5.8. So it means hx based on the values of a, b, and c, hx equals 0.6 x squared minus 3.6 x plus 5.8. So this is the updated design. Just now, we already find the original design. This is the original design function, and this is the updated design. This one. Right. Next question. Okay, hence find A, B, and A, B, and C already. Okay, F, that's F already now. G, Andrew claims the updated design will still provide a smooth path for a person using the slide. Okay, explain why Andrew's claim is correct at the point where x equal to, right? Okay. Uh, if x equals 2, okay, first, the condition, provided for the design, for the original design, I mean, for the original design, uh, as h derivative 2 is equal minus 1.2. Okay. This one we have calculated. This one. Okay. The gradient is minus 1.2. Afterwards, and the updated design uh, if h derivative 2, it as well equal minus 1.2. This is the information. This one. Okay. So, based on this information, for both curves, gradient are the same. Okay. So whether original design and updated design, they have the same gradient. Next, for x equal to original design, uh, that I'm writing here, original design. For original design, uh, H2 equal 0.2 times 2 cube, 0.9, 2 squared plus 3. If you calculate this, result equal 1. And for updated design, H2 0.6, 2 squared, 3.6 multiplied by 2, 5.8, 1. So look the result. So we can state that for both curves, whether original design or updated design, they have the same height. Okay, the heights are the same.